Hey there, Year 10 VCAL students, Mr. Herman here. This is a video tutorial looking at the exercise on ratios. This here is from the log sheet work of log 4 ratios, simplifying, and there's also log 5 ratios, dividing ratios. This tutorial is going to be both for log 4 and log 5 from the pattern and number area study. So ratios, obviously you've heard this term before. You've heard that a ratio has to do with something to do with splitting, or maybe you've heard the terminology in relation to fractions or parts. A ratio is just a way of comparing like quantities, and by like quantities we mean the same type of forms of quantities. So for example, let's just say if Alan has a sporting equivalent of tennis balls, then Alan has 3 tennis balls, and Jake has 1 tennis ball, we can write the ratio of Alan Jake equals 3 1. Now those 2 little dots that you see, this little semicolon, we pronounce this as 2 TO. So the ratio of Alan to Jake for these tennis balls is 3 to 1. So Alan has 3 and Jake has 1. If the ratio, just be careful, if the ratio, we wanted to know what the ratio was for Jake to Alan, the order does make a difference. This will be 1 to 3. So the order does make a difference depending on how many tennis balls are associated with each person. So in this case, Jake has 1, so you put the number 1 first, and then Alan has 3, with 3. Just for this hypothetical example, okay? So just be careful, order does make a difference. In this case here, if we do double the number of tennis balls for each person, so that Alan has 6, and then Jake has 2, so this one here, we just double it, 6 to 2. We can still write this as a ratio of 3 to 1, and this is because for every 1 tennis ball that Jake has, Alan has 3 tennis balls. And so it is correct to say the ratio can be written as 6 to 2, but to use a simpler version of this, we can simplify this down to 3 to 1. Okay, so it just really depends on the scenario of how many tennis balls each person has all up. If that's irrelevant and we just want to see the ratio, you would simplify this down from 6 to 2 to 3 to 1. And how we simplify this, if a ratio can be simplified, it's just a matter of finding what's called the highest common factor. So we're going to look at that in this example here. We're going to convert the statement Sandy has $9 and Leslie has $15 to a ratio in simplest form. So in this case here, how you would approach this is Sandy to Leslie has a ratio of 9, because Sandy is first, $9 to $15. So right now we know that Sandy has $9 and Leslie has $15, but this can be simplified because there is a common factor. This can be reduced down to a simplified version. What you do is you try to find what the highest common factor is. What number can go into both 9 and 15 that is the biggest number, because we know there is a few numbers that can go into here, but the biggest number that can go into both 9 and 15 is 3. Now, how many times does 9 go into 3? What you do is you divide this 9 by 3, and you also divide this 15 by 3 as well. You divide by the highest common factor. In this case, 9 divided by 3 is 3, and 15 divided by 3 is 5. And so what this simplified version of this ratio is saying is for every $3 Sandy has, Leslie has $5. Okay, and we know this because all up Sandy has $9 and Leslie has 15. So if you did the reverse of this, if you were to multiply this by 3, you would get back to the initial ratio of 9 to 15. This right here is just the simplified version, or a simplest form. This here is the simplest form. So when you're working out ratios with a question like this, you have to make sure that it goes down to its simplest form. We're now going to see the more application side of ratios. And so here is an example that has to do with coloring and paint. So a certain paint color is made by combining these 3 tints within this ratio. So 3 tints, tint 1, 2, and 3, and you can just imagine the tints could be like different colors. In this case here, Tint 1 requires 1 part, Tint 2 requires 2 parts, and Tint 3 requires 4 parts. So this is just saying for every one that we have of Tint 1, we'll change the color. Tint 2 has 2 parts, and then Tint 3, let's choose one more color, a random color. Let's go that color there. Tint 3 has 4 parts, so 1, 2, 3, 4. So this here, this is Tint 1, I'll just put T1, this is Tint 2, and this is Tint 3. 1, 2, and 4 respectively. If you mix this all up, you will get the required color, whatever this color is, from these ratios. Okay, and this is how color is made, or paint is made when you're deciding a paint color for a wall. They mix different paint colors through certain ratios that they get told. So if you go to Bunnings or wherever paint place you go, they mix these paints together to get a required color. And it's just a matter of just mixing different fragments of colors to get your desired one. So if you had a certain green that was maybe a bit lighter or darker, it depends on what the ratio of paints are. And it can be more than one paint. In this case here, we've got 3 paints. You can have more than 3 paints in this case. Sorry, my wife came in with some yum yum food, so I just ate some yum yum food. All right, so this question here, this is in the form of a ratio: Tint 1 to Tint 2 to Tint 3, 1 to 2 to 4. Okay, so we've got a 1 part to 2 parts to 4 parts. Now we can use as many numbers as we can within a ratio, but what I care about is how many total parts are there all up. Before I even answer the question, how many parts are there all up? 1, 2, 3, 4, 5, 6, 7. So this is made up of 7 parts, okay, all up. And so what the question is asking for, if 70 mils of paint is needed in total, how much of each tint is used? How much do we need of each tint? So obviously we need a certain amount of this, certain amount of this, and certain amount of this, that when we combine it all up will give us 70 mil. And we know, if you haven't clued onto it yet, we know that it has to do with these 7 parts. So how do we tackle this type of question? The first thing we need to do is, once we've added all the parts up, we need to see how many of these parts go into what our total is. So how many 7s go into 70? Or in other words, if we have 70, let's split it up into 7 parts, or 7 sections, 7 units. This ends up being 10. So in other words, we have to multiply these 7 parts, the Tint 1, Tint 2, and Tint 3, we have to multiply this by 10 to get the 70 mil. And so now what we're going to do is grab this 10 and we're going to distribute it to each part. So in other words, I'm going to times T1 by 10, T2 by 10, and T3 by 10 to get the required parts. And this should add up to 70. So the first one, put in a different color here. So the first one, we're going to multiply this by 10. So 1 part times 10 is just going to equal 10. This one here, 2 parts, we're going to multiply this one by 2. So 2 times 10 parts, this is equal to 20. And the last one, 4 parts, I'm going to get 4 parts. Whoops. Consistency, need this color. There we go. 4 times 10. This is going to revolve 40 parts. So let's just make sure that we got 70 parts all up. 10 plus 20 is 30 plus 40, which gives me 70. So there are 70 parts or 70 mils all up. So how much of each tint is needed? Tint 1, I'm just going to call T1, T2, and T3. Tint 1 is 10 mil because we're dealing with mil. T2 is 20 mil. And T3 is 40 mil. So this is nice and simple because we know that these 7 parts easily goes into 70 mil. And so 10, 20, 40, just add them all up to make sure that we got 70 mil all up. So how we tackled this, remember, is add up all your parts and then divide it into what the required amount is, and then distribute that amount by multiplying by each part. And this could happen more than 3 times. You can have 5, 6, 7, depends on what the ratio type of question is. But it's gone too far, there we go. This example here, simplifying ratios, I'm going to show you how you can get from one version of a ratio to the other using your scientific calculator or the Desmos website. We're going to write this ratio of 750 ml to 2 liters in its simplest form. Now, what you can see here is that this set of unit conversions shouldn't just be written as 750 to 2. This is incorrect, and this is because these unit measurements are not the same. So we need to figure out, well, how many milliliters are there in 1 liter? There's 1,000, so there needs to be 2,000 in 2. So you got to make sure that the unit conversions are exactly the same. So 250 mil to 2,000 mil. This is our first part of the ratio. Now this can be simplified down further down, so it's written as 750 to 2000. This can be simplified down to 3 to 8. Now how would you do this is you can just simply use your calculator. What would you would do is you would just put this in the form of a fraction. So 750 on the top and 2000 on the bottom. And this will spit out the simplified fraction version of 3 to 8. Or 3 over 8. You would just write this as 3 to 8. This would be the simplified version down. Okay, so just make sure you don't write it as a fraction. You got to write it as a ratio. But this is in its tongue twister simplest form. All right, last example here before you tackle the set questions. We've got 2 business partners invest in the company in the ratio of 7 to 8. The business makes $90,000 profit in 1 year. We're going to divide the profit according to the ratio of 7 to 8. So think of an investment as for every, we'll call them stocks, and that's the terminology. One of the businesses buys 7 stocks and the other business buys 8 stocks. So obviously business 2 has 1 more extra stock. So we're expecting that business 2, whatever the business is going to get just a little bit more money than business 1 because they didn't get as many stocks in. And so the profit that they made is $90,000. So what's happening is once the profit has been calculated, this gets sent out to to this business. So for every $7 that business 1 gets, or business 1, called B1, it's bananas and pajamas, B1 and B2. So for every $7 that B1 gets, B2 gets $8. And this is going to keep going. $7 to business 1, again, $8 to business 2. This is going to keep going until all the $90,000 has been completed. Now, obviously, this is going to be a tedious way, so we're going to utilize a skill that we just learned before of how to figure this out. So the first thing we need to do is, if it's to the ratio of 7 to 8, we need to figure out how many parts that is all up just by adding the 2 together. So 7 plus 8 is going to give me 15 parts. Okay, so every single time that the ratio goes out, the 7 and the $8, it ends up being $15. And then we do this again, another $15. Business 1 gets 7, business 2 gets 8, and then another $15. And this keeps going until we've run out of money. We need to know how many times we're doing these payouts from the $90,000. All we need to do is get our 90,000 and divide this by 15. And this will tell me how many iterations there are that we need to distribute this money accordingly. So 90,000 divided by 15. So we're going to do this 6,000 times. We're going to do this 6,000 times. So we're giving business 1 6,000 lots of $7 and business 2 6,000 lots of $8. So let's work this out. 6,000 multiplied by 7, and this will end up giving us 42,000. So business 1, B1, 42,000. Now, like I said initially, I'm expecting business 2 to get more money because they've got one more lot of stocks within this within the profit. So we're going to get 6,000 multiplied by $8, and let's see what business 8 gets. Yep. Times 8, 48,000. So business 2 gets $48,000. Now let's just double check to make sure that this gives us exactly $90,000. 42,000 plus 48,000. Yep, that's $90,000. Check. So we've distributed out the shares accordingly correctly. Okay. So how do we do this again? We looked at the ratios 7 to 8. We added up the total parts, which was 15, and this 15 was divided into 90 to see how many times we have to distribute this out. In this case, it was 6,000. So 6,000 over here and 6,000 here. So remember, this ratio, just like we saw in the previous exercise, the previous example, can be split up into more different parts. You could have a ratio of 1 to 2 to 2 to 2 to 2 to 1. That could be maybe money distribution out to siblings. All you care about is how many parts there are. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Split that 10 parts into whatever the total is, and then distribute it out accordingly. Okay. So the set questions that you need to do, guys, from the log sheet. Here's the log sheet set questions. So log 4, 24.5 ratios. We pretty much tackling questions 1 all the way to 7. So ratios is one of the set exercises which is going to take a while for you to do. So you've got the 2 lessons to complete this for the Thursday. Where you find the set questions, obviously the resources are up on Compass in the relative folder. It's 285. That's the page. Exercise 24 ratios. The actual questions itself, these are the examples that I showed you, which I already did up on just Photoshop before. 24.5 to page 287 is where the questions start. You're tackling questions from 1 all the way to 7. Okay, this component here is actually quite an important component because you will get quite a few ratio type questions within your common assessment tasks. So make sure that you hone into this skill as much as you can, and you're 100% confident in tackling these type of questions. If you need any help, I'm on Microsoft Teams. Just send me a team message chat. My best advice is the set notes that I wrote. Copy them down into a book. Because you will be using those notes to help you out when it comes to the common assessment task. Best of luck, guys. If you have any questions, you know where I am. I'll see you guys soon.